listening to Emma equals MC squared, a podcast where I can help you learn or review about science in a fun and fast way too. Please leave a comment or review in the comment section below so I can help others learn about science in a good way. I'd like to keep these as ad-free as possible, so please support me by checking out my store link in bio, where I sell lots of fun posters and products, and some of them do, in fact, relate to the podcast. Now, to the episode. Welcome to Periodic Table Driver's Ed. If you're older and already have your driver's license, you thought you could get away from another test. Afraid not. As we all know, well, hopefully all know, that the periodic table is a table with a bunch of squares in it that have symbols and numbers. These are like the signs in a driver test. You need to know how to read them so then you know the correct directions to take. The number in the top left, or the bigger number in the sense that it is larger in value than the other one, it's often on the top left, is the atomic mass. This is the number of protons and neutrons combined together. On the bottom left or the center top, depending on what periodic table you're looking at, is the atomic number, or the number of protons. With this, we now know how to figure out the number of electrons by subtracting the atomic mass by the atomic number to get rid of the protons and just be left with the neutrons. Now for how streets, in a sense, work on the periodic table. We have rows and columns. The periodic table has special names for these. A column is called a group or a family. Think of a well-behaved elementary class student in a perfectly straight line, or family members in a line of oldest to youngest. Next is a row. It is called the period. Think of a sentence and how a period goes at the end of the sentence. Now it's time for metals and nonmetals. I'm not going to give you the exact area. I'm going to be more specific in the titles of metals and nonmetals. The first family is the alkaline metals, and the second family is the alkaline earth metals. Be sure not to mix these up because they are different. Then from families 3 through 12 is the transitional metals. Again, more metals. Then we have a staircase on the periodic table. Be sure to not trip on the staircase because then you will mix up nonmetals and metals. Quite different things. The staircase is marked out by aluminum, germanium, antimonium, and palladium. Or their symbols are Al, Ge, Sb, and Po. Down from these elements, it is metals, and above of these elements on the staircase, to family 17 are non-metals. Last, we have the snooty noble gases. I like to think of them as the king at the head of the table, refusing to mix with anyone else. I know, they're so rude. Ridiculous. Now for the more scientific stuff with longer explanations. It's more of the directions on how roads work, in a sense, on you gotta go straight here or left here, use the right or left lane. We have, first off, electronegativity, where we bring back the valence electrons as briefly mentioned in the first episode. Now, valence electrons, there can only be up to 8 of them, and we'll get more into that in the bonds episode, which should be next. If it's less than halfway full, then it takes less energy for it to lose an electron, so it's easier for something else with a higher electronegativity to take it away. If it is more than half full, then it's harder to lose an electron and easier to take an electron. This increases from bottom to top and from left to right. Ionization energy luckily moves in the same direction as electronegativity, so you don't need to memorize 2 different directions for these two. This is kind of like electronegativity, just worded a bit differently. It is the amount of energy required to remove an electron from a neutral atom in gas phase. Next, we have the atomic radius, which is half the distance between the nuclei of 2 atoms, because, remember, that electrons are in a cloud of probability and we're not 100% sure where they always are, so we have to measure from the 2 nucleus and chop it in half. Now, elements with more protons and neutrons have a stronger nucleus attraction, which means they have a stronger pull on the electrons, making the electrons come closer to the nucleus. So, if it has more protons and neutrons, it'll pull the electrons closer, making it smaller and having a smaller atomic radius. So this moves from right to left and from top to bottom, the opposite of electronegativity and ionization. Congratulations, you have passed the driving test of the periodic table. I hope you enjoyed, and I'll see you next time. Thank you so much for listening. I really hope this helped, and thank you so much. I really appreciate you listening to this. Be sure to leave a comment below and let me know how I can improve, and to check out my store. Until next time, Emma equals MC squared, out.